You ever ask a search engine a question, and instead of just a list of links, it pulls out the one perfect sentence you were looking for? It really feels like magic, right? Well, today we're going to pull back the curtain on that magic trick. We are going to demystify how AI basically acts like a digital highlighter, finding exactly what you need in a huge sea of information.
We've all been there. You've got a very specific question, and you need that answer now. You type it into the search bar, you hit enter, and you just cross your fingers and hope something clear and simple pops up.
But instead, you usually get this, the classic wall of blue links. It's a list of documents that might have the answer, but now the real work starts for you. You've got to click, scroll, and sift through all of it to find what you're looking for. I mean, it works, but it's not exactly efficient, is it?
Because let's be honest, what you really want isn't a list of possibilities. You want the answer served right up to you.
For instance, if you ask, what are minimalist shoes? You don't want a long article about the history of footwear. No, you want this exact snippet. This is the magic we're going to break down, how an AI can read a super long document and pull out this one perfect phrase.
And this shift is a massive leap in how we find information. We're really moving beyond just finding documents and into the world of true question answering.
Okay, so the technical term for this whole process is extractive question answering. And extractive is the really important word here. The AI isn't making up an answer or summarizing something, it's literally extracting a direct quote, a specific chunk of text from a document that already exists.
So how on earth does it do that? Well, a great way to think about it is to imagine the AI as this super intelligent digital highlighter. But instead of just highlighting what looks important, it's been trained to find the single most probable answer to your very specific question. What's really fascinating is how the AI simplifies this. It doesn't actually need to understand the text in the way a human does. Nope. Instead, it treats it all like a probability game. It looks at every single word in the document and calculates the odds that that specific word is the start of the answer you're looking for.
And then, you guessed it, it does the exact same thing for the end of the answer. It runs the numbers for every word, trying to figure out which one is the most likely final word. By finding the most probable start and end points, it identifies what they call a span of text. And that span, well, that's your answer.
Okay, so that makes sense for, one document. But a real search engine has millions, maybe billions of pages. Forcing the AI to read every single word of every document for every single question would be unbelievably slow and super expensive. So how do they solve this massive problem of scale? Well, the secret is this absolutely brilliant two-step system. So you can't have one slow, heavy-duty tool read everything. It would just take forever. So instead, you use two specialized tools, and each one has a very, very specific job. This is called the retriever-reader pattern. So first up, you've got the retriever. Think of it like a super-fast librarian. It doesn't actually read the books, it just scans the entire library in a flash and pulls a few documents that are most likely to have the answer. Then, and only then, does the reader come in. The reader is like the subject matter expert. It carefully reads just that small handful of documents to find the precise answer.
And here's how that teamwork breaks down. The retriever's whole goal is speed and recall. Find every potential source from the entire library without missing anything important. The reader, on the other hand, is all about precision and accuracy, carefully reading just a few pages to pull out the one right answer. This combination gives you insane speed at a massive scale, plus pinpoint accuracy. It's really the best of both worlds.
So, this system is an amazing piece of engineering. It's fast, it's efficient, but a basic model might not be very good on a really specialized topic, like, say, medical research. So how do we take this generalist system and turn it into a genuine expert? The answer is a process called fine-tuning. And this is where human expertise becomes absolutely critical. We take a powerful, pre-trained AI model, and then we train it even more. But this time, we use a custom dataset of high-quality, perfectly labeled examples that are specific to our topic. To do this, we usually create two kinds of datasets. We start by having an existing AI take a first stab at answering our questions, which quickly creates what's called a silver set. It's a decent starting point, but it's probably full of mistakes. Then, human experts have to go in and meticulously review, correct, and curate that silver set, turning it into a golden set. This golden set is the ground truth. It's the perfect data we use to teach our AI how to be a real expert.
And this right here is the crucial point.
The quality of your AI is directly tied to the quality of its training data. A model is only ever as good as the golden set it was trained on. This human-in-the-loop process is what separates a pretty good model from a truly great one.
Now that sounds like a lot of work, right? Hours of manual labeling, correcting the AI's mistakes, carefully building this perfect data set. Does it actually make a difference in the end? Is it worth it?
Oh, absolutely. After fine-tuning a model on a custom golden set all about the outdoors, they ran a validation test. The result? The model found the correct answer 7 out of 10 times on brand new questions it had never seen before. That's a really powerful demonstration of how this process creates a reliable and accurate expert. Okay, let's put it all together. Here are the 3 big things to take away. First, that magic of finding an answer isn't real understanding. It's a super clever probability game of predicting the most likely start and end words. Second, the retriever-reader system is the engineering trick that makes this whole thing possible at a massive scale, balancing speed with accuracy. And finally, what turns a general AI into a true expert is fine-tuning it with a high-quality, human-verified golden set of data. The human expert is still the secret ingredient. So everything we've talked about today is what's called extractive AI. It's all about finding a needle in a haystack. But the next frontier is abstractive AI. That's an AI that doesn't just find quotes, but actually reads multiple sources, synthesizes the information, and then generates a brand new answer in its own words. If today's AI is like a digital highlighter, tomorrow's AI might just be a digital author.